Hey, what's up guys, my name is Cherno, and welcome to the 8th episode of my Flappy Bird series. Today we'll be creating a shader class to handle our shaders. As mentioned earlier, shaders are programs which run on the graphics processing unit in our graphics cards. Since we want to draw graphics using the graphics card, we need to tell it what to do. To make the interaction between our game and its shaders easier, we're going to create a shader class. This class is basically going to be static, but we'll leave the constructor as public for now. It'll take in the paths of both our vertex and fragment shaders. Let's make a field called ID, which will store the ID of the shader program. We'll load in our shaders using the shader utils class we created. Next, we'll make a static method that will load all of our shaders. This will be called once when our game starts. Since we have no shaders right now, let's just leave this blank. We need a way to activate and deactivate our shader programs, so let's create enable and disable methods. Let's import GL20 and call GLUseProgram with the ID of the current shader to enable it. To disable it, we simply call GLUseProgram with a shader ID of 0, which is essentially null. This disables any active shaders. We also need a way to send data from the CPU to the GPU, or essentially from our game to our shader. There are two ways to do this, uniforms and attributes. We'll cover attributes later, but let's make a quick method to grab the location of uniform variables in our shaders. Uniform variables are variables in our shader program that are given values from our actual program. This method will return the location of the uniform variable with a specified name so that we can set it. Usually we'd go ahead and create a bunch of methods that set certain uniform variables, but we're not going to waste too much time on that. I will create a method, however, that sets a 3-component vector in our shader. We'll call it setUniform3f, and it'll take in the name of the variable as well as a vector 3f. We'll use our getUniform variable to grab the location, and use the components of our vector as values. OpenGL's GLUniform3f method will set the uniform at the specified location to the specified values, as expected. Let's test out this class. Back in our main class, we'll simply swap out the shader code with our class, and enable the shader. It should work as expected, but the code looks a bit nicer, and we now have more control over it. Let's modify our fragment shader to include a uniform variable. This will be a vec3 which will contain the color of our triangle. We'll update our output color to reflect this uniform variable, and switch back to our main class. Let's set our shader's output color to a nice red from our game using the setUniform method we created, and run our game again. Nice, the triangle is now red. We didn't exactly statically create this shader, so let's change that. Back in our shader class, we'll create a static instance called basic, which will represent this basic shader that we've just created. I'll also set the constructor to be private to force instantiation in this class alone. In loadAll, we'll instantiate the basic shader. Back in main, I'll set our shader to shader.basic, and make sure to call loadAll after we initialize OpenGL, but before we use our shaders. Let's run the game again and marvel at the identical result. Thanks for watching, and I hope you guys enjoyed this video. As always, a like is greatly appreciated. Next time we'll talk about projection matrices and set them up in our shader. Goodbye.